Alright, now I'm going to demonstrate how to calculate the time to a VOR station in the aircraft. The first thing I've done is tune and identify the Westminster VOR at 117.900 for the first and second VOR instrument. Here I've got the course deviation indicator needle centered on the 350 radial. I have a 2 flag indicating that we are going to the VOR station directly. I've also got my stopwatch over here. I'm going to reset it to 0, and now the digital stopwatch is ready to go. I've got the altitude and the navigation mode selected on the autopilot so that it will free up our hands just for the purpose of this demonstration. And we can also see here on the Bendix King DME, it's giving us information in terms of distance to the VOR station and what our ground speed is, and that will come alive once I unpause the simulation and it's getting live data. So what we're going to do is we're going to fly directly to the VOR station. Then we're going to make a 90-degree detour so that we're flying perpendicular to the VOR station. As we start our turn perpendicular, in this case from south to west, the needle will start deflecting. We'll hold off until we get to our 90-degree offset. So once the aircraft stabilizes flying due west, we'll see that the course deviation indicator needle is deflecting to the left. We'll wait till it gets right on one of these tick marks, which is 2 degrees apart. So every dot is a 2 degrees, all the way up to 10 degrees total. So we'll wait till it gets to the first tick mark. The moment it gets here, we will start the stopwatch. We'll let it pass through 2 or 3 tick marks, and then we'll stop the start watch, and we'll reposition the aircraft so it's pointing south again to go back towards the VOR. Now, you can think of this estimate kind of like an average. So the more data you collect, the better your average estimate of the amount of time it takes to the VOR station is going to be. So when we let the needle line up to this dot and then start the timer, the more deflection you allow the needle to get to before you stop the timer and then reposition the aircraft back to the VOR station, the better your estimate should be, theoretically speaking, in the calculation. So once we get to the first tick mark, I'll let the needle swing all the way to 10 degrees. You don't have to, but in this case I will. I'll let it get all the way to 10 degrees. I'll stop the timer, and then I'll reposition the aircraft back to due south to retrack the VOR station. So now I'm going to unpause the simulator, and we are now flying. I will switch over to the heading mode on the autopilot. I'll swing the aircraft around to a heading of due west, and we'll see the aircraft is moving in response. And we're passing in through to the 240 heading, and we can see the course deviation indicator is starting to swing slowly. Now we're coming in on due west, and the needle is at 2 degrees deflection to the left, so we start our timer right now. And we'll stop the timer once the course deviation indicator needle gets all the way to the end, which is 10 degrees total variation. And we're holding due west, which is 90 degrees perpendicular to our course to the VOR station. Now we're coming in through 4 degrees deflection. Now we're coming in through 6 degrees deflection. Here we're coming in through 8 degrees deflection. And finally, we're going to wait till we get to a total or full scale deflection of 10 degrees offset. And we're passing through. and coming up on 10 degrees total deflection right about now, and I'll stop the timer. So that took 1 minute 15 seconds. We'll reposition the aircraft so that we go back to the course that we wanted. We want to go to the VOR station, so I'll take us back to a heading of south, and I'll also give it about a 20-degree lead so that instead of going due south, we'll go about 160 to 170, because we've been flying to the right of the station, so we want to go back a little bit towards the left to get us realigned. So now we're coming back in, and we'll just hold this heading until the CDI needle slowly starts to walk back in. And as it starts to walk back in and center itself, we'll switch from heading tracking back to navigation tracking, or we could just switch to navigation tracking right now. Either way should work. The aircraft will hold this heading until the needle starts swinging in. And what we'll notice is that our distance is a 17.7 nautical miles to the VOR station, and our ground speed is 115 knots, which will help us verify the amount of time it will take to get to the station. It's kind of a double check.